Hello everybody, welcome into the very first lesson of Precalculus. So today we are going to talk about lines in the plane. So this is probably going to seem very rudimentary, very basic, that a lot of you are probably already familiar with. First topic today is the slope of a line. So the slope denoted as m is the change in y over change in x, or delta y over delta x, which is of course equal to your y2 minus y1 over your x2 minus x1. So let's say we have a couple of points here we want to find the slope between. We're being asked to find the slope between the points 0, negative 10, and then 4, 0. So we want to find the slope between the points 0, negative 10, and 4, 0. Well, why don't I plot those points to show you about what we're looking at here. Here's 0, negative 10. Here's 4, 0. So we want to find the slope of that line right here, going through the points 0, negative 10, and 4, 0. And looking at this, you would say it should be a positive slope, and you would be correct. So what is that slope? Well, the slope is going to be your second y coordinate of 0 minus your first y coordinate of negative 10 all over your second x coordinate, which is 4, minus your first x coordinate, which is 0. So 0 minus negative 10, that gives you 10 over 4, which would be 5 halves. So the slope of the line from 0, negative 10 to 4, 0 would be 5 halves. And I got more. This time, what if we try to find the slope of the line between, let me write in the other color. We're going to find the slope between 2, 4, and then 4, negative 4. So we're going to find the slope of the line between 2, 4, and 4, negative 4. So here's 2, 4. And then here's 4, negative 4. So looking at this, you're going to say that's a very steep negative slope. And again, you'd be correct. That is a very steep negative slope. So what is that slope? Well, that's going to equal your y2 of negative 4 minus your y1 of 4 all over your x2 of 4 minus your x1 of 2. Well, this would end up giving you negative 8 over 2, or simply negative 4. So the slope of this particular line would in fact be negative 4. All right. This time, let's see, we have the point negative 6, negative 1, as well as negative 6, 4. So we're going to find the slope between the points negative 6, negative 1, and negative 6, positive 4. 1, 2, 3, 4, 5, 6. Here's negative 6, negative 1. Here's negative 6, 4. Well, notice you get a straight up vertical line. If we remember right, the slope should be undefined for a vertical line. If we remember Vux-Hoy all the way back from pre-algebra, we've been talking about Vux-Hoy ever since then. Vertical line, undefined slope, x equals. So to find the slope, take your y2 of 4 minus your y1 of negative 4 over your x2 of negative 6 minus your x1 of negative 6. Well, this would end up being 4 minus negative 1. That'd be 5 all over negative 6 minus negative 6. That'd be 0. We know anything divided by 0 is undefined. So the slope is undefined, and you have a straight up vertical line. One more for finding the slope, then we'll move on. All right. So we have negative 3, negative 2, and then we have 1, 6. So let's find the slope of the line between negative 3, negative 2, and 1, 6. So here's negative 3, negative 2. Here is 1, 6. So let's just connect those points. Yikes. So you would also be saying that's going to be a positive slope, and it sure is. Well, what is that slope? Let's find said slope. So this would be m equals your y2 of 6 minus your y1 of negative 2 all over your x2 of 1 minus your x1 of negative 3. So this is going to equal 8 over 4, so the slope of that line would be positive 2. So that's finding the slope of a line. That should really be a review at this point, and I'm sure it was to everybody. And as I said in the welcome video, a lot of this is going to seem like a review, but it's important that we do it. Alright, so now we can talk about something called the slope-intercept form of a line. So this also will seem like a review. Slope-intercept form of a line, that's going to be something like y equals mx plus b. And this is how your functions occur too. Your functions will always be in this notation for a linear function. Instead of seeing y, you'll see f of x equals mx plus b, where m is your slope and b is your y-intercept. So that's why it's called the slope-intercept form. Y equals mx plus b. So we're going to do a few equations here. So let's see. So what if we had 5x minus y plus 3 equals 0? Well, we want to find the slope and the y-intercept. So we're going to find the slope and y-intercept. Well, right now we have this in general form. We need to convert this to slope-intercept form. We can easily do that if we get the y by itself. So we can make this y equals 5x plus 3. So what is our slope? Our slope is 5. That's the coefficient on the x, so the slope would be 5. The b, the y-intercept, that's going to be at 0, 3. So the y-intercept would occur at 0, 3. And if you're going to plot this, it also wouldn't hurt to find the x-intercept, which would be when y is 0. So if you set 5x plus 3 equal to 0, you would get 5x equals negative 3, x would equal negative 3/5. So let's find negative 3/5, 0. That'd be about right here. And that's roughly how you graph the line. You would graph the line like so. And if you put it into a graphing utility, like a graphing calculator, you should get something that looks about like that. In general, you want to have your x and y intercept when graphing a line. All right. So we have 2x plus 3y minus 9 is equal to 0. So we have 2x plus 3y minus 9 equals 0. We want to get this into slope-intercept form so we can find the slope and the y-intercept. So get the y by itself. So you would have 3y would equal negative 2x plus 9, which would give you that y equals negative 2/3 x plus 3. Now we have this in slope-intercept form. We know the slope is going to be negative 2/3. So there's your slope of negative 2/3. Your y-intercept, your b, is also at 0,3. So 0,3 again right there. Now it also doesn't hurt to find your x-intercept. Well, you can just put it into the original equation because the x-intercept occurs when y equals 0. That would give you 2x equals 9. X would equal 9/2, which is 4.5. So right there is your x-intercept, and now let's just plot a continuous line through those points. And there's the line graphed, and that's about what you should get if you put this into a graphing calculator. All right, a couple more lines to plot here. Now, what if we just had something like this? 5x minus 2 equals 0. We just got 5x minus 2 equals 0. There's no y. So we know this is going to turn into x equals, isn't it? So we could just solve for x. That would be 5x equals 2. So x would equal 2/5. This is where Vux-Hoy comes in handy. If it's just x equals, you use Vux. Vertical line, undefined slope, x equals. So the slope is undefined, and it's going to be a vertical line through x equals 2/5. So that's really what you're going to get, is just a straight up vertical line through x equals 2/5. That would be the graph of 5x minus 2 equals 0. And which means there is no y-intercept. So if you have a vertical line, unless it's x equals 0, that would be the only time you have a y-intercept, because it would just be the entire y-axis, but there is no y-intercept in this case. As you see, it doesn't cross the y-axis. All right, then on the flip side, what if we had 3y plus 5 equals 0? So we have 3y plus 5 equals 0. You don't see an x. If that happens, just solve for y. So 3y would equal negative 5, y would equal negative 5/3. So remember Hoy, horizontal line, 0 slope, y equals. So the slope is going to be 0, and it'll be a horizontal line through y equals negative 5/3, which would be negative 1 2/3. So right about here, it'll be a continuous horizontal line through y equals negative 5/3, and which means your y-intercept, of course, is going to be at 0, negative 5/3. So you have no x-intercept unless it would be straight up y equals 0, then it would be the entire x-axis, but it has no x-intercept, but your y-intercept is at 0, negative 5/3. So that's bringing back Vuxhoy. All right. Now, we want to find the general form of an equation. So general form or standard form, you may see it listed either way. They both mean the same thing. General standard form of the equation of a line, it's going to take one of two forms. Ax plus by equals c, or you may see it listed as ax plus by plus c equals 0. It depends what textbook you use. It may have it listed either way. Ax plus by equals c, or ax plus by plus c equals 0. Either form's correct for the general standard form of a line. So we need to find the standard form of an equation through a line. And also another one that's going to come in handy is the point slope form. Point slope form. Some of the exercises are going to require us to use point slope form. So that's going to be your y2, not y2, what am I saying? That's going to be y minus y sub 1 equals your slope m times the quantity of x minus x sub 1. So the point slope form is very useful if you know the slope and only one point on the line. And then from here you usually don't leave something in point slope form. This is how you start out. And then from there, you're either going to convert it into slope-intercept form or standard form. For these next few exercises, we're ultimately going to go to standard form. So let's go ahead and do some of these. So we are given the point 0, negative 2, the slope is equal to 3. Well, we actually have it pretty easy. We have the y-intercept and the slope. We can straight up start out with slope-intercept form. That's going to be y equals that slope of 3 times x plus your y-intercept of negative 2. So this is the slope-intercept form, but they want general form or standard form. Well, you would want to get that constant on one side, get your x and y terms on another side, so this would just turn into 3x minus y equals 2. So that's what they'd be looking for the general form. 3x minus y equals 2, or some books may write it as 3x minus y minus 2 equals 0. Either way would be correct. All right. This time we're given the point negative 3, 6. We're given a slope of negative 2. So since we don't straight up have a y-intercept, we have some other point, negative 3, 6, and we have a slope, you're going to want to use the point slope form to find the line initially. So that's going to be y minus your y1, which is 6, is going to equal your slope of -2 times the quantity of that x minus the x1, x minus -3, that's x plus 3. So this would give you y minus 6 equals -2x minus 6, which in short would give you y equals -2x. That would be for the points, that would be for the slope-intercept form, but they want the general form. So the general form would just be 2x plus y equals 0. So that would be your general form, 2x plus y equals 0. Alright, so we have the point 2, -3 with a slope of -1/2. Alright, so we have the point 2, -3 with a slope of -1/2. Well, let's use our point slope form again. So this would be y minus your y1 of -3, so minus -3, this turns into y plus 3, equals your slope of -1/2 times the quantity of your x minus your x1, so that'd be x minus 2. So this becomes y plus 3 equals -1/2 x plus 1. Well, this would become then y equals -1/2 x minus 2. We have it in slope-intercept form. We need it in general form. So put your constant term on one side. Get your constant term on one side. So this would turn into 1/2 x plus y equals -2. But if you want it in general form, you have to have integers for your x and y coefficients. It's never acceptable to leave it as a fraction or a decimal. So you're going to multiply everything by 2. You would end up getting x plus 2y equals -4. So in general form, this is going to be x plus 2y equals -4. Alright, we go through the points -2, the point -2, -5, where the slope is 3/4. So we're going through the point -2, -5, where the slope is 3/4. So use your point slope form. This would be y minus your y sub 1, which is minus -5, that'd be y plus 5, equals your slope of 3/4 times the quantity of your x minus your x sub 1, so minus -2, that'd be plus 2. So this should give you y plus 5 equals 3/4 x plus 3/2. Alright, so let's get the y term by itself to start. This would become y equals 3/4 x minus 7/2. Now we want to, if we're going to start to convert this into general form, we need to get the x and y terms together on one side and get the constant term by itself. So this would turn into 3/4 x minus y equals 7/2. But again, we can't have a fraction at all for general form. So multiply everything by 4. You definitely want to go based on your coefficients. So this would turn into 3x minus 4y equals 14. That would be the general form of this equation. 3x minus 4y equals 14. All right. So now we're going to shift gears a bit. We're going to find the slope-intercept form of an equation of a line that passes through 2 points. And we're going to graph the line. So we're given 5, negative 1, and then we're given negative 5, 5. So 5 negative 1's right here. 1, 2, 3, 4, 5. And then negative 5, 5's here. So we want to find the slope-intercept form of the equation of this line. Well, we're going to have to use point-slope form. But first, we need to find the slope of the line, right? We got to find the slope. So that's going to equal your y2, which would be 5, minus your y1, which is minus negative 1. That'd actually turn into 5 plus 1, all over your x2 of negative 5, minus your x1 of 5. So this would end up giving you negative 6/10. Which means your slope would be negative 3/5. Now that we know the slope, we can use the point-slope form. So that's going to be y minus your y sub 1. It does not matter which point you pick, but once you pick a point, you got to stick with that point for both your x and y coordinates. But either way, you should get the exact same result. Let's pick 5, negative 1. So y minus negative 1, that would turn into y plus 1, would equal your m of negative 3/5 times the quantity of x minus your x sub 1, so x minus 5. So this would give you y plus 1 equals negative 3/5 x plus 3, which would give you y equals negative 3/5 x plus 2. So the equation of this line in slope-intercept form would be y equals negative 3/5 x plus 2. Alright, another one. So we're going to find the slope-intercept form of the line between the points 4, 3rd, or going through the points 4, 3rd, 4, 3, and negative 4, negative 4. So let's see. 1, 2, 3, 4. Here's 4. So there's 4, 3. Here's negative 4, negative 4. So this is the line we need to find the slope-intercept form of the equation for. So first, let's find the slope. So m is going to equal your y2 of negative 4 minus your y1 of 3 all over your x2 of negative 4 minus your x1 of 4. So this would give you negative 7 over negative 8, meaning your slope would be 7/8. So positive 7/8 is your slope. Okay. Now we need to find the slope-intercept form of the equation, but we need to use point-slope form first. So that's going to be y minus, pick a point. I'm going to pick 4, 3 since there's no negatives. So y minus 3 equals my slope of 7/8 times the quantity of x minus 4. So y minus 3 would equal 7/8 x minus 7/2. We're almost there. Just get the y by itself and we have slope-intercept form. So y would equal 7/8 x minus 1/2. So the equation of this line in slope-intercept form would be y equals 7/8 x minus 1/2. All right. Find the slope of the line between -8, or if not the slope, but the equation of the line, -8, 1, and then -8, 7. So here's -8, 1. Here's -8, 7. So we need to find the equation of this line in slope-intercept form. And yes, it's a straight up vertical line. So let's find the slope itself. M would equal your y1 of 7 minus your y2 of 7 minus your y1 of 6 all over your x2 of -8 minus your x1 of -8. That would turn into +8. So you would end up getting 6/0. So your slope is undefined. So that means we're just going to have the form x equals. So the best you could do is x equals -8. Or simply you could say that x plus 8 equals 0. That would probably be the best you could get for your slope-intercept form. You would just get that x plus 8 equals 0. You'd have a continuous line going through x equals -8. A continuous vertical line, I should specify. All right, let's flip this around a bit. How about -1, 4, and then 6, 4? -1, 4, and then 6, 4. So yes, you have a continuous horizontal line going through. So let's find the slope here. Slope is, of course, your y2, which is 4, minus your y1 of 4, all over your x2 of 6, minus your x1 of -1. This would be over 6 plus 1, which would just give you 0. So we have a horizontal line, slope is 0. This is a continuous horizontal line through y equals 4. So literally the best you're going to get is y equals 4 for the slope-intercept form. You'll just get y equals 4. All right, let's shift gears again here. So also we can use slope to determine parallel and perpendicular lines. So we remember then that parallel lines if two lines are to be parallel, what you're going to get then is that the slope of the first line exactly equals the slope of the second line. That's how you know that the lines are parallel. Now, if they're going to be perpendicular, that means the slope of the first line is equal to the negative reciprocal of the second line slope. So what you should get then is that the product of the first slope times the product of the second slope would equal -1. That's what you should get every time. The product of the first slope times the second slope would equal -1. So let's see. We're going to do some examples here. We're going to determine if some lines are perpendicular, parallel, or neither. So line 1, you got the points 0, -1, and then 5, 9. Line 2, you're given the points 0, 3, and 4, 1. We need to determine, are these two particular lines, are they parallel, perpendicular, or neither? Well, let's start out by finding the slope. So let's find the first slope, m sub 1. This will be the slope for line 1. That'll be your y2 of 9 minus your y1 of -1, so 9 plus 1, all over your x2 of 5 minus your x1 of 0, so 10 over 5 equals 2. Slope of the first line's 2. How about the slope of the second line? M sub 2, that's going to equal, so y sub 2, which is 1, minus your y sub 1, which is 3, all over your x2, which is 4, minus your x2, which is 1. So this would end up then giving you -2/4, which would be -1/2. Well, they're not the same slope, so they're definitely not parallel. Now, we can look at 2 and -1/2 and definitely determine that that's the reciprocal, that the second slope is the negative reciprocal of the first slope, so they're perpendicular. So we could say that line 1 is perpendicular to line 2. Or if you really want to, you can multiply the first slope times the second slope and get -1. And you would still determine it's perpendicular. But based on that, the line 1 is perpendicular to line 2. All right. So let's see, line 1 is goes through -2, -1, and 1, 5. Line 2 goes through the points 1, 3, and yes, 5, -5. So let's determine, are these two lines parallel, perpendicular, or neither? So let's find the first slope. Slope of the first line, your y2 is 5 minus your y1 of -1, so this would become 5 plus 1 over your x sub 2 of 1 minus your x sub 1 of -2, so this would become 1 plus 2. You get 6 over 3, which is 2. Now let's find the slope of the second line. So y sub 2, which is negative 5, minus your y sub 1, which is 3, over your x sub 2, which is 5, minus your x sub 1, which is 1. So you get negative 8 over 4, which would give you negative 2. Well, they're not the same slope, so they're not parallel, and they're not negative reciprocals of each other. If you multiply the slopes of the two lines, you would get negative 4. So these two lines are neither. Which, if we remember from geometry, if two lines aren't parallel, that means they intersect at some point. So they do intersect at some point, but they're neither parallel nor perpendicular. All right. You know, why don't I take these down real quick for the last set of exercises? We're going to do 3 more, then we'll be done with the lesson. All right, so we got to find a couple things here. We have a point 2, 1. This is outside of a line that they give us 4x minus 2y equals 3. They want us to first find the slope-intercept form of a line that goes through point 2, 1 that is parallel to 4x minus 2y equals 3, and also perpendicular that goes through this line to 4x minus 2y equals 3. Okay. Well, over here on the right, we should get this into slope-intercept form so we know the slope, right? So this would end up being 2y equals 4x minus 3, which would mean y equals 2x minus 3 halves. So the very slope of this line that they give us is 2, right? The slope is 2. We'll call that m sub 0 or m sub original. That equals 2. If we're going to find a line parallel to that line through the point 2, 1, that means that we have to have the same slope as this line, right? So that means y minus your y sub 1, which is 1, would have to equal your slope of 2 times your x minus your x sub 1, which is 2. So that would give you y minus 1 equals 2x minus 4, which would give you y equals 2x minus 3. So the line parallel to this line going through the point 2, 1 is going to be y equals 2x minus 3. Now what about perpendicular? What if we want to find a perpendicular line? We know that a perpendicular line would have a slope that's the negative reciprocal of the original. The negative reciprocal of 2 is negative 1/2. So take your y minus your y sub 1, which is 1, set that equal to your slope of negative 1/2 times x minus your x sub 1, which would be 2. So you would get y minus 1 equals negative 1/2 x plus 1, which would give you y equals negative 1/2 x plus 2. So the line going through the point 2, 1 that is perpendicular to 4x minus 2y equals 3 is y equals negative 1/2 x plus 2. So that's how you find parallel and perpendicular lines. And we got more. Got 2 more I'm going to do. Then we'll be done with this lesson. Alright, we're going to go through the point negative 3, 2. It's outside of the line x plus y equals 7. So first we want to find a line going through the point negative 3, 2 that is parallel to the line x plus y equals 7. Let's convert that x plus y equals 7 into slope-intercept form. That's going to be easy. That would just be y equals negative x plus 7, which means your slope of the original line would be negative 1. So that's pretty easy. The slope would be negative 1 for this line. So to find a parallel line, now all you have to do is take your y minus your y sub 1, which is 2, set that equal to your slope. Since it's going to be parallel, it'll have the same slope of negative 1, or simply the negative of the quantity of x minus your x sub 1, which would be minus 3. So this would be x plus 3. So y minus 2 would equal negative x minus 3, which means y would have to equal negative x minus 1. So in slope-intercept form, the line parallel to this line would be y equals negative x minus 1. Now let's find a perpendicular line. Well, the perpendicular line has to be the negative reciprocal of the slope of the original line. The negative reciprocal of negative 1 is positive 1. So this would just be y minus your y sub 1 of 2 is equal to positive 1 times the quantity of x minus negative 3. So y minus 2 equals x plus 3. So y equals x plus 5. So the line running through the point negative 3, 2 that is perpendicular to this line is y equals x plus 5. And let's do one more. Let's do just one more here. They're going to throw some fractions at you. The point negative 2/3, 7/8. And then it's outside the line 3x plus 4y is equal to 7. Alright, so we have a little bit of a doozy. We want to find first a line parallel to 3x plus 4y equals 7 running through the point negative 2/3, 7/8. First we need to determine the slope of this 3x plus 4y equals 7. So get the y by itself. So 4y would equal negative 3x plus 7. So that means y would equal negative 3/4 x plus 7/4. So that means the slope of the original line, m sub 0, is negative 3/4. That means if you want a line parallel to this line running through this point, you need to use the same slope of negative 3/4. So now let's go for the parallel line. So that's going to be y minus your y sub 1, which is 7/8, equals your slope of negative 3/4 times your x minus your x sub 1. So x minus negative 2/3, that'd be x plus 2/3. So y minus 7/8 would equal negative 3/4 x minus 1/2. So then you would get y equals negative 3/4 x plus 3/8. So the line that is parallel to this original line running through negative 2/3 7/8 is y equals negative 3/4 x plus 3/8. Now let's find a perpendicular line. Now what's true for a line perpendicular? The slope has to be the negative reciprocal of the original. So the negative reciprocal of negative 3/4 is positive 4/3. So to go through this point, you'll take your y minus your 7/8, set that equal to that 4/3 times your x minus negative 2/3, so that'd be x plus 2/3. So this is going to be y minus 7/8 would equal 4/3 x plus 8/9. Yeah, this is not looking pretty, is it? Not at all. We need to add the 7/8 and 8/9. So this will become y equals 4/3 x plus 8/9 plus 7/8. Pretty sure the only common denominator between 9 and 8 is going to be 72. So y is going to equal 4/3 x plus 64 70-seconds plus 63 70-seconds, which would mean y equals 4/3 x plus 127 over 72. And I don't think the 127 reduces any further, so this is the best you can get. The line perpendicular to this line through the point negative 2/3 7/8 is y equals 4/3 x plus 127 over 72. So that's it for this lesson. Next lesson we're going to talk about functions, just generally about functions. So I hope everyone has a great day. Take care.